Welcome to our bridge design masterclass. So this is the part 7 of our series in bridge design, where we are designing both the reinforced concrete bridge and the prestressed bridge. So today we want to model the prestressed concrete bridge. So this is the cross section of the bridge of the prestressed bridge, which is made up of the overall road width of 10 meter, and we have the carriageway width of 8 meter. Then we have the spacing of the main girders, which is the prestressed uh, beam at 2 meter. So we want to model this prestressed bridge using Autodesk Structural Bridge. Okay, so this is what we have already done in a previous model. So we want to proceed with the modeling of this bridge in Autodesk Structural Bridge. So let's quickly open the software. Okay, so when you want to start a new project, by the time you launch the software, so you click on new. When you click on new, under design code, this is where you select the code that you want to use for your design. So here we are going to use the British standard, which is the BS5 400 for our bridge design. And if you want to use the Euro code, you can also pick the Euro code here. If you want to use the Euro code plus UK annex, so whatever other code that you want to use, so you can just come here and select your code. So in our case, we want to use the British standard. So when you select the code, the next thing you do is to select the retention prestress, because you want to model the prestressed concrete bridge. So you click on retention prestress and you click on project, click on OK. Now we want to set our template so that maybe subsequently we can be using that in our design. So for you to set the template, you come here. When you click on file, you come to where you have title. Click on title. Then under project title, so I want to say MAC dissertation. Okay, let me say MSc bridge design 60 meter, 60 meter. We can say 60 meter longitudinal length So here job title, just allow prestressed bridge design. So we can call this one part 1. So bridge number, you can call this 4. Designed by, just put a short form of my name, and I will click on OK. Okay. So now that I've set the template, so the next step is for us to define our material. So you come to where you have the material. If the material doesn't appear here, you simply come here to click. Whatever that you want to appear here, just click on that. If I want the beam design, I will click on it. Whatever that I want, I will simply click on it. So we want to work with the material. So I'll click on the material, right click, go to add. So the first thing I want to add, because we are working with BS 4500, which is the code for the design of bridge. So we are working with BS 500, 5400. So I will click on concrete, click on that. Now, the concrete, for the first concrete strength I want to define is for the beam, is for the beam. So I want to define the concrete for the beam. So for beam, we have the concrete grade for our beam is 50 C 50 stroke 60. Now this is actually the code definition of the concrete. So in BS we don't have this combination, so we are going to adopt C50. So I will come here, click here, C50. This is actually for the beam. This is actually for the beam. This is actually for the beam. So the moment I'm done with that, I will simply click. I will click OK. Click OK. Now the next material I want to begin is still concrete, but this one is going to be for the slab. I'll still come to concrete. So here I will change this to 30. Press enter. So for the slab, we have C30 stroke 37. So because we are using the Euro code, so that will be our FCU to be 30. So I'll click OK. So I've defined the concrete strength for the main gate, that is for the pre-stressed beam. I've defined for the slab. The next property I want to define will be the steel. So I will still come back to material property, come to add. Now, under reinforcement, I will click on BSDs. Now, here we are going to use 410 instead of 500. We are using 410 instead of 500. So this is for why I'm using the high yield steel is for the is for the is for the structural element that will have the high yield steel. So I have to define that as part of my property, my material properties. So I will click on OK. I will go back again because we have the high yield steel, then we also have the wire strength. So I will add the wire strength. So in this case, the wire strength I'm going to use is going to be pre-stressed strength BD 4 stroke 9454. So this is what I'm going to use. So here, once you click on this, you don't change anything. You just allow the characteristic strength of that wire strength to remain 1820 Newton per millimeter square. So you click on OK. So I'm done with adding up material. So the next thing I want to do is to add my beam, my beam, design beam. So I will click on this. So when you click on this, you right click, come to add. Now here you have to be very careful because we are working with pre-stress. We are working with pretension pre-stress. So we are working with pretension pre-stress. So you click on new pretension pre-stress. New pretension pre-stress. So our beam length is 30. Our beam length is 30. Now, it's 30 meter. Now, that is the span length. The span length is 30. That is from support to support is 30. But the overall longitudinal length of this bridge is 60 meter. So we are going to define the span length, which is 30. So the span length here is 30. So you define 30. Okay. Now, our type of prestressed beam is Y beam. The type of prestressed beam is Y beam. That is what we adopt for this design. That's what we adopt for this design. So let me look at it here. So we have the Y beam. For the reinforced concrete, we have the rectangular. Okay. So we select the Y beam. Select the Y beam. And here the beam, the spacing of the beam is at 2 meter, that is 2000 millimeters center to center. And when you notice this, you see that when the spacing was at 100, we have the Y7, that is the wire strength type. But when we increase the spacing to 200, now with increase of spacing to 200, the bridge experience a heavy loading compared to when the spacing was at 1000 or 1 meter. So here the loading is not really being felt by even though the loading is heavy, but it is being controlled by the the numbers of the increase in the numbers of beam. But here you notice that the beam number here will be decreased. For instance, let me explain further here. Let me explain further here. Now you look at this. You look at this. Now assuming that the spacing was at 1 meter, so you realize that the numbers of pre-stressed main girder will now be this. It will be double of this, because here we will have another bar. So we have another beam, 1, 2, 3, 4. So if we have 4 here, so that will be, if we have 1, 2, 3, 4, so that will be 5, 6, 7, 8, 9. So that will be 9 numbers instead of 5. So, and when you have 9 numbers, you realize that the load is reduced, because those load will be absorbed by the numbers of beam that you have. But the moment the spacing of the main girder reduces, so the load will increase. The load that will come on each of these beams will be increased. So that is the logic behind this. And as a result of that, we will have the the wire strength here would be increased to Y8. Okay. So we click on OK. We click on OK. Now, this beam has just uniform section. It doesn't have different section. In other words, we don't divide this section into two. That is why we are going to maintain uniform. Assuming that we have varying section, maybe from here to here we have a a, a different section or the stage, even though the section might be one, but we have different stage. Maybe let's say stage 1 from here to somewhere here, then here we have another stage, then we would have adopt varying section. But here we have just uniform, so we don't need to click on varying. Instead, we click on uniform. So when you click on uniform, you check here that you have just a section. But if you click on vary, you notice that you have two sections. So you have 1, 2. That is why you have 1, 2 section. Then we are working with a uniform section. So that is why we have just numbers of different sections is just 1. So you click on section. So when you click on section, you notice that what we have here is just the pre-stressed beam. There is no slab. So we want to add slab to it. So this is PCB, which is precast beam. So you want to add slab to it. You want to add slab to it just to look like this. Just to look like this. To look like this. But but the slab that we are going to add there will just show the section. It's going to be the section. This section is going to be divided by 2. So this section, this is how it will look like. This is how it's going to look like. So the section that we are going to define now is going to be from here to here, which is half of this spacing and half of this spacing. So now to add slab, okay, here, if you notice this under the precast beam, if you notice the property of the concrete here is C30, so we can change this. Okay, we can change this. Now for the slab, you simply come here, click. So when you click here, you come to institute regular because it's going to be an institute slab. You click on institute regular. So the spacing is 2 meters. So remember that the spacing from the center to here is 1 meter. From here to here is also 1 meter. But from beam to beam is 2 meters. So we are picking center to half of the spacing. So this will be 2 meters. Then for the depth, which is the thickness, so we are going to use the global. We are going to adopt the global analysis. So meaning that we are going to adopt 250 institute slab thickness, which will now include the 50 thick precast concrete slab, the precast concrete slab for global analysis. So that is what we are going to do. So here we come here, we click on 250. So when you click on 250, you click on OK. Now click on OK. Now if you click OK, it will show a kind of error until you mesh. You have to mesh by stage. Okay, let me just show you. So you can now see use the mesh by stage button to modify the institute. So you come here, you click mesh by stage. So when you click on mesh by stage, I think we are done with that. Okay. So now I want you to notice that this beam that we have just finished modeling is an interior beam. This is an interior beam. So we will also model the exterior beam. Then we have to finish everything with the interior beam before we now move to the external beam. So here we are done. The next thing we will do is for us to place at the reinforcement. Okay, let's look at how the tendon look like. This is the tendon. This is a tendon. This is a tendon. So this is the standard beam. Standard beam. This is a standard prestressed beam. Okay. So as you can see here that when you look at the section of this slab, there is no reinforcement. So we want to place the reinforcement. Okay, so you click OK. Then for us to do that, we come here under reinforcement. Okay. Now look at what it says. It says no data to display. Fine. There's no data to display. So what we do, we come to this plus sign and we click on it. So when you click on it, under generate, you have the drawbar. The drawbar, you have 1 bar by 2 cover. You have reinforced face. So we are going to use reinforced face. Then by position, we are going to use exact spacing. So here we have to define our spacing. So I will set my temporary spacing to be 150. Then the diameter of the deck reinforcement I will allow Y20. I will allow Y20. So when I'm done with that, I will simply click on. I'll simply click on. Okay, sorry about that. Okay, let's go back. So we go back here. We go back here. Click OK. Come here. Click exact spacing. Then because we are choosing reinforced face, so we have to come here. Click on the reinforced face. Then click on this. So when you click on that, this will now display the reinforcement. So the next thing is you click on OK. So now if you want to change anything here, you can. If you want to change anything here, maybe the characteristics or the grade of the grade of the steel, you simply click here. Then you use control A, and when you use control A, you can come here, edit reinforcement attribute. But we are not going to do anything. We are not going to edit anything. So everything will remain the same. So you simply click OK, and you click OK here. Now we are done with the first modeling. We are done with the first modeling. So we can now click OK. So when you click OK, the next thing is for us to run the analysis. We want to run the analysis. Now the analysis that we want to run is for the differential temperature, because the differential temperature, you can check for differential temperature using the section without actually designing the beam. So we have to run the analysis. So you click here. Okay. So we have just run the analysis. Now you come here where you have analyzed for. Now we want to analyze for differential temperature primary stress. Want to analyze for differential temperature primary stress. So here under group, you don't touch anything here because it's already the code has selected the part and the fixture that is being used. So here you come here, you will see different options. Different options. You see steel deck on steel box girder, steel deck on steel trusses or plate girder, concrete deck on steel box truss or this, concrete slab stroke deck on concrete beam. So this is the one that has to do with us. So you click on it. So when you click on it, under surfacing it is surface. Under surfacing it is surface. Then depth of concrete above steel is 0.2. Then surfacing thickness, all these are default. So you allow it at default. You click on OK. Then the next thing you will check is for shear, is for shrinkage and creep. So you simply click on that. When you click on it, you are not going to do anything. You are not going to change anything here. You simply click on OK and click on OK. So we are done with this. Now let's go back to our AutoCAD, the long trainer. Now the one that we have just finished modeling is this one, this inner beam 1, 2, 3. That is what we have just finished. So we want to copy that to represent this other one here, to represent this, because in Autodesk Structural Bridge, you model this structural element one after the other. So we have just done with these three. We want to do for these other three. So for you to achieve that, you simply come here, right click, go to copy. Okay, I can rename this. Let me rename this. Let me rename this to interior. Let me rename this to interior beam, interior beam, interior bridge beam 1. Okay. 1. Okay. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. So the next thing I want to copy, so let me just copy it. Okay, so let me rename this. Let me rename this. So I will call this interior bridge beam beam 2. Interior bridge beam 2. I'll click on it. Now, when you check these beams, this beam and this beam are the same. This beam and this beam, they are just the same. Now, had it mean that this beam and this beam were not the same, maybe there was this thing here, I would have just come here and just reverse this, maybe to change the direction of the support from here to here, but they are the same. So I will not change the direction. I would have just come here and click on reverse, but they are the same. So nothing will really happen to it. Okay, so every other thing remain the same. Every other thing remain the same. So we don't do anything here. Okay, so now we want to model the external bridge, the external girder. So we simply copy this again. So when we copy this, we rename it. We rename this external external bridge beam 1. So we can call this knot, or we can, let's look at what we can call this. So now let's call this right. No, let's call this left and call this right. So we are working with left. So we can call this left 1 and this will be left 2. Okay. So we come here, we say beam, okay, 1 left, can call it left. Okay, we can call it left 1 left. You click on it. So this is external beam now. So let's work on this. Let's model the external beam now. So now when you check, let me just show you the difference between this external beam and the internal beam and the external beam. Now the external beam, the internal beam, if you cut the section here, if you cut this section from here to here, okay, I think let me use this to show. Let me use it to show. Let's go back to the section. Okay, now this is how the section of internal beam look like. Because from here to the center here is 1 meter, and from here to the center here is 1 meter. So by the time you check, the overall now become 2 meter, which is the actual spacing of the girder. Okay, but for the external beam, it is not like that. You have to understand that from here to here is 1 meter, so half of it will be 500, and from here to here is 2000, so half of it will be 1000. So this will now be 1005 instead of 5, instead of 2000. So you have to. So let's select the section. So the section that we are going to use here is going to be YE, which is the YN. So we select the spacing, we click on OK, select the spacing, we click on OK, then we change this to exterior beam, then let's go to the section. So you can see how this section look like. So this is the section, but when you check this section, you see that it's still giving us 1 meter. So we are going to define it again. we're going to define it again. So we come here, come to institute regular. So here we are going to change here. We're going to change this to 1.5. Changing this to 1.5. And you click on OK. So now when you look at this, you see that the 1.5 that we have just imputed is actually from the section we have from here to here to be 750 and from here to here to be 750 also. No. So what we do is that we will move this by 250 so that we can have from here to here to be 1000 and from here to here to be 500. So to achieve that, you simply come here and you put 250. So you can see that it has driven this. So from here to here is 1000, and from here to here is 500. So now, so here we have the parapet. We have the parapet. We have the parapet. So we want to put the parapet now. So for you to define the parapet, you simply come here, come back to Institute Regular again. Then here you select stage 2, stage 2. Okay, so we come here. So we are going to define that. So the width of our parapet is 200. Now the the height of our parapet is 1.5, which is the depth 1.5. So click here. So when you click here, we want to move this to this edge. So to achieve that, we simply come here and say minus 600. So it has moved that. Now to bring it down, remember that the thickness is 250. So what we do here is that we say 1620 minus 250. So that will give us 1370. So here we say 1370. Okay, 1370. So we have been able to achieve that. We have been able to achieve that. What again? Okay, we click on match. We can make. Okay, so you can now see that we have been able to create the external beam. But there is something that has happened here. If you check, the reinforcement has projected out. So we want to correct that. So we come to where we have reinforcement. So we just highlight this. Let's just highlight it. Then we come to this place where we have minus. We click on it, and that's it. So that's okay. So we have done this. We have done this now. So you click on OK. Click on OK. Now this is for the left one, which is this is what we have just finished. This is the one that we have just finished. This one. We just finished this one. So we want to model this one. Now the good thing is that we can simply copy this one because all the arrangement are just the same. So we come here, come to this one, right click, click on copy. So when you click on copy, you right click again, come to rename. So we can now rename this one. So we can rename this one as okay, external bridge, external bridge beam, bridge beam, okay, 2. So we call this one left again. This is still left. Okay. So that is it. So when you click here, everything remains the same. Everything that we have. don't remain the same. So let's check our interior bridge being 1, fine. Okay, we can check the section. So let's look at the section. So this is how the section look like. So we can close interior bridge being 2. You also check the section. The section is the same. So we can close. Then external bridge being 1 left. So you check the section. So these are the section look like. These are the section look like. So you close that. Then external bridge being 2. We look at also the section. Then we can look at the tendon. This is how the tendon look like. You want to move this, you can move. Okay. Okay, so this is where we will stop. So this is where we will stop. Then we continue in our next module. Okay. Bye.